Let's work this example. Researchers are conducting an experiment to see if a given therapy works to reduce test anxiety in a sample of college students. A standard measure of test anxiety is known to produce a mean of 20. In the sample of 36 randomly selected students that received the therapy, the mean was 17, and the standard deviation was 9. Is this strong evidence to suggest that the therapy is effective in reducing test anxiety? Let's let our alpha be equal to 0.05. So this is quite a long problem. I want to go through and sort of tease out some information we can get from this paragraph. The first thing I want to think about is this means or proportions? Below, I have either changed the font color or made bold some important things that stand out to me when I read these problems. One of the first things I see that it says it's a standard measure. So that's sort of indicating to me that this is a measurement. And we know measurements often require means to summarize them. And if you read even further in green, we see the word mean twice over, and then it's complemented with a standard deviation. So these clues here are showing me that this problem has to deal with means. The next question I want to ask myself, if I've decided now that it's about means, is what informs my hypothesis statements? And what I've done here in this slide is I've shown you the parts that are informing the hypothesis statements. They're the ones in italicized gray. You can see I have a statement here, and then I have a statement at the end. What I wanted to point out to you is the part in the red brackets here. This is the actual evidence that the researchers collected, and this does not inform our hypothesis statement. They're just simply sharing with us what they found, but the parts that are in the italicized, a standard measure of test anxiety is known to produce a mean of 20, followed up with, is this strong evidence to suggest that the therapy is effective in reducing test anxiety? These are the parts that are going to help us write our hypothesis statement. Let's write the hypothesis statements for this problem. We've already discussed that the problem revolves around means. So this means that both of my hypothesis statements will involve our friend mu. This is the population parameter for means. We also emphasized that the important parts of the problem that were in the italicized gray said that the standard measure for test anxiety is known to be 20. So I'm going to put that in the null hypothesis. The other portion at the end asked us if this was significant evidence to show that the test anxiety measure or mean has decreased, or if it was effective in reducing test anxiety. That means my alternative hypothesis will be that the mean is less than 20. Let's check out the assumptions and conditions for this problem. First assumption we want to check is if randomization was involved. And we're in luck because the researchers chose a random sample of 36 students. The next thing we'd like to know is if we could assume independence. We have to feel comfortable assuming that each student's score on an anxiety test is independent of another student's score. And I believe that's easy enough to assume. Finally, is our population data stated to be normally distributed, or do we have at least 30 in our sample? In this case, we weren't told about the population data or the population distribution, but we do know that we had 36 students that they used in their research. So thus, our third condition checks out. This essentially tells us that we can use the t distribution to solve this problem. this brings us to our third step, where we sketch our problem and then use StatCrunch to help us find some of the important values. So the last step told us that we could use the t-distribution. So I drew a t-curve or t-distribution here. Looks a lot like a normal curve. And underneath, I'm going to label the mean. Well, they told us that the standard measure or value for a test anxiety score was 20. That's what the null hypothesis told us, so that's what I'm going to put beneath the center of my distribution. I'm also going to now calculate the standard error, which is S divided by the square root of N. In our problem, the standard deviation was stated to be 9, and we have 36 students in our sample. So if I take 9 divided by essentially 6, that equals 1.5. So this is our standard error. We're going to do 3 tick marks equally spaced to each side. Let's see, I'll then start to subtract the standard error. So this will bring me to 18.5. This will bring me to 17 and 15.5. I think I'm just going to label the left side here. I could also label this side if I wanted to. So this is the model according to the null hypothesis. So we want to see how our sample data fits into this, the actual evidence that the researchers collected. So they told us that when they collected the information, the mean of those 36 students was 17. So what I'd like to do now is put that into here. And it just so happens, it doesn't always happen this way, that our data falls directly on a tick mark. Now this was a left-tailed test, so we're going to shade to the left. Our alternative hypothesis had a less than in it. So what I've done for myself now is create a really nice sketch that's going to inform me on what to expect in StatCrunch. So I'm going to also guess and gauge. Here I'm going to go count how many tick marks away my evidence the red value fell. It looks like t is equal to -2. So we'll also see that emerge when we do our problem. So our t-stat will be the number of tick marks away our data fell, our evidence fell from the hypothesized mean, and our p-value will be this red shaded area. Let's jump into StatCrunch.
To solve this in StatCrunch, go to Stat, t-stat, so that we can use the t-distribution. We only had one sample, and we were given a summary. Once we get to this pop-up box, you will see it's asking us some familiar questions because of the information we have. What was our sample mean? 17. The sample standard deviation was 9, and our sample size was 36. StatCrunch just wants to know the evidence in this problem. The next thing it needs to know is, what did your hypothesis statements look like? Well, here is the mu we expected because we're testing a mean, and our mu was equal to 20, and our alternative hypothesis was a less than. That's all you need to enter in to have StatCrunch perform this hypothesis test for you. Click Compute. The pop-up box will come in with what we need to know. You can see here that the t-stat is indeed -2. That's what we expected from our sketch. That's why we sketched to begin with, so that we know that StatCrunch is giving us what we anticipate. And also that small shaded region to the left had an area of 0.0267. That is our probability value, otherwise known as a p-value.
StatCrunch provided us with some nice information. We learned that the shaded region here, the probability value, or p-value for short, is equal to 0.0267. And also it reinforced that our tick mark indeed was, which corresponds to our t-stat, -2. So let's see if we can take this information here. When I make a decision, have a good practice of writing the p-value first. I'll state the alpha that we were given, and that was 0.05. That was initially, notice I haven't talked about alpha the entire problem until we get to step 4. I haven't used it in any of my calculations, nor did I put it into StatCrunch. It comes in right now to help us with a threshold of unusual. So this is commonly spoken as 5%, or as a proportion 0.05. This is where we would judge if anything that happens less than that, as this one is, we would say that that event is indeed unusual and would cause us to doubt the truth of the null hypothesis. So we have some pretty significant and compelling evidence here that came about from our mean being 17. It produced an area to the left that is quite small, as we can see, in comparison to our alpha. So when our p-value is smaller than alpha, we reject the null hypothesis. We're at the last step where we'd like to communicate the results in a summary statement. So let's recall what our null and alternative hypotheses were. The null hypothesis said that the mean test anxiety score is known to be 20. The alternative claimed that it would be less than 20. Our decision was to reject the null hypothesis in step 4. So we'll reject it. And when we reject the null hypothesis, we're left with the alternative, which says that the mean is less than 20. So what we're walking away from this testing process with, after using our evidence to check it out, is that the mean is indeed less than 20. So let's write a summary statement. The sample data suggest that the mean anxiety score, I guess this was a test anxiety, is less than 20. So I want to do a follow-up statement here, which simply says the therapy is effective in reducing test anxiety. So this concludes our hypothesis testing process.